explaining the unified medium framework, a field-theoretic model for gravity, matter, and spacetime. Agenda: Introduction and motivation. Core fields of the unified medium, dynamics and field equations, gravity and rupture zones, matter, energy, and dark matter. Cosmology and scaling relations, comparison, strengths, and summary. Introduction and motivation. Introducing the unified medium.
Fragmented foundations in physics. Gravity, quantum fields, and thermodynamics use distinct theories. A unified medium proposal suggests all physical phenomena arise from a single underlying medium. Three interacting fields: density S, directionality U micro, and coherence psi. Exploring new possibilities. Unifies gravity, electromagnetism, and quantum effects in one framework. Addresses singularities, matter formation, and dark matter. Why unification is needed.
Disjoint foundations in physics, general relativity, and quantum field theory operate independently. No single framework unites gravity with quantum phenomena. Unresolved puzzles remain. Singularities, dark matter, and quantum measurement lack unified explanations. Current models struggle with these foundational issues. Promise of unification. A unified medium could bridge gaps and resolve inconsistencies. Potential to explain matter, gravity, and quantum effects together. Core fields of the unified medium. The medium: three interacting fields.
Three fundamental fields. Scalar density S encodes local gravitational strength. Vector field U micro governs directionality and electromagnetic-like effects. Coherence field psi underlies quantum phenomena and phase correlations. Unified medium dynamics. All physical behavior arises from interactions among S, U micro, and psi. Fields are continuous and differentiable, supporting both stable and oscillatory excitations. Emergent physical phenomena. Gravity, electromagnetism, and quantum effects are unified as manifestations of the medium. Scalar density field S.
Local density field of the medium. Sx quantifies the density at each spacetime point. Physical, not just geometric, directly influences dynamics. Source of gravitational effects. Gradients in S generate gravitational attraction. Density waves in S correspond to gravitational waves. Critical density and rupture zones. S has a maximum value Sc, setting a physical upper limit. When S approaches Sc, rupture zones form. Spacetime collapses locally, but avoids singularities. Directional field, UMEM, encodes local directionality. UADX defines preferred directions and flow within the medium. Determines how excitations propagate through spacetime. Electromagnetic-like dynamics. Perturbations in UWCA mimic Maxwell's equations in the weak field limit. Supports wave propagation similar to electromagnetic fields. Coupling to density and coherence. UWCA interacts with scalar density S and coherence psi fields. These couplings influence anisotropies and wave behavior. Coherence field psi.
Quantum coherence encoded in Field-Theoretic. Field-Theoretic is a complex scalar field capturing the medium's coherence. Determines quantum phenomena, interference, entanglement, and phase. Role in matter and stability. Stable matter forms when C common maintains non-zero amplitude and phase structure. Coherence field stabilizes density fluctuations, enabling persistent configurations. Collapse near rupture zones. As density S approaches critical value Sc, right pointing arrow 0. Loss of coherence signals breakdown of quantum correlations in rupture zones. Dynamics and field equations. Unified Lagrangian dynamics.
Unified Lagrangian structure. Single Lagrangian density couples S, UWCA, and psi fields. Respects Lorentz symmetry and supports stable field excitations. Kinetic and coupling terms. Kinetic terms for S density, UWCA, directional, and psi, coherence. Nonlinear couplings encode interactions between fields. Rupture threshold potential. Potential enforces a maximum density C, preventing singularities. Diverges as S approaches C, triggering rupture zones. Field equations and interactions. Field equations from unified Lagrangian Euler-Lagrange equations govern S, U in, and psi dynamics. Each field's equation encodes distinct physical effects, emergence of physical phenomena. Density field S supports gravitational waves as density oscillations. Directional field UA, Maxwell. Like behavior in weak field limit, coherence field psi, quantum interference, and phase dynamics. Nonlinear couplings and unification. Coupling terms link gravity, electromagnetism, and quantum effects. Interactions stabilize matter and mediate phase direction effects. Gravity and rupture zones. Emergent gravity and effective metric.
Gravity from density gradients. Gravitational effects emerges variations in the scalar density field S. No need for fundamental spacetime curvature. Gravity is a medium response. Effective metric via conformal transformation. The effective metric is defined as G_EFF equals omega squared S eta, where omega S depends on local density. This metric governs the motion of all excitations in the medium. General relativity in the weak field limit. For small density variations, the effective metric reproduces Newtonian gravity and GR predictions. Gravitational waves correspond to oscillations in the density field S.
Geodesics and gravitational waves.
Excitations travel along effective geodesics. Motion of matter, coherence and waves is governed by the effective metric derived from the density field S. Geodesic equation depends on local density gradients, not on fundamental spacetime curvature. Gravitational waves as density oscillations. Small perturbations in S propagate as waves, analogous to gravitational waves. These are compressions and rarefactions of the medium, not metric fluctuations. No fundamental geometric fluctuations. Spacetime curvature is emergent, not fundamental. All effects arise from field dynamics. Gravity is a manifestation of density variations, not changes in geometric structure. Rupture zones. Beyond black holes.
Critical density triggers rupture. When the density field S nears its critical value SC, the medium cannot compress further. This initiates the formation of a rupture zone, preventing singularities. Collapse of spatial volume. Within rupture zones, spatial volume contracts dramatically but remains finite. No infinite density points are formed. The core has a well-defined size. Breakdown of coherence and directionality. The coherence field psi collapses, erasing quantum correlations. Directional structure UEB becomes disordered, halting electromagnetic-like behavior. Structure of rupture cores. Core radius defined by density threshold. Rupture core boundary at SR equals RC equals C. Sets finite core size. Suppression of coherence fields psi. Inside the core, psi approaches zero, quantum coherence collapses. Directional field UEK becomes disordered. Loss of electromagnetic-like structure within the core region. Exterior mimics Schwarzschild solution. Outside the core, density transitions smoothly. Weak field gravity matches standard black hole behavior. Information and coherence loss. Collapse of coherence at rupture threshold. As the density field S approaches its critical value SC, the coherence field psi rapidly diminishes. Quantum correlations and phase information cannot be maintained within the rupture core.
Information encoded at rupture boundary. Rather than being destroyed, information is preserved in the nonlinear structure at the rupture boundary. The interplay of density, directionality, and coherence at the boundary encodes the lost information. Unitarity preserved in the unified medium. No fundamental violation of unitarity occurs. Information is not lost from the perspective of the full medium dynamics. The apparent loss is a result of coherence breakdown, not true destruction. Matter, energy, and dark matter. Matter as stable configurations.
Matter as stable medium structures. Particles are localized, persistent configurations of the unified medium. Balance of fields ensures stability. Stability requires interplay among density, S, directionality, U and UO, and coherence psi. Perturbations must not grow unbounded. Stable modes oscillate. Mass energy as medium energy. Mass arises from energy stored in density and coherence fields. E equals mc squared interpreted as conversion of medium energy into stable matter. Thermodynamic loading, and E equals mc squared. Energy conversion in the unified medium. Input energy is stored in density, S, and coherence, psi fields. Thermodynamic loading can trigger formation of stable matter. E equals mc squared as medium energy conversion. Mass arises from internal energy of density coherence structures. E equals mc squared expresses conversion of medium energy into mass. Stability and coupling constants. Stability depends on interplay of G1, G2, and G3 couplings. Stable matter resists perturbations. Unstable forms dissipate. Dark matter as density fluctuations.
Dark matter as medium fluctuations arises from transient density stabilization fluctuations in the unified medium, weakly interacting mass-like excitations. These fluctuations behave as mass-energy packets, similar to WIMPs. They are transient but statistically persistent in regions seeking density uniformity. Gravitational coupling only. Fluctuations couple through the density field S, producing gravitational effects. No coupling to the directional field U micro, no electromagnetic interaction. Minimal coherence signature. Exhibit little to no coherence via psi, making them invisible to quantum and electromagnetic probes. Cosmology and scaling relations. Cosmological structure formation.
High density, coherent early universe. Unified medium began with elevated density S and strong coherence psi. Directional field UIC exhibited minimal anisotropy. Density gradients drive structure. Small fluctuations in S amplified, attracting more medium, led to the emergence of protostructures and large-scale patterns. Coherence field smooths fluctuations. Psi field stabilized the medium, damping small-scale irregularities, allowed large-scale structure to form while suppressing noise. Galaxy and rupture zone scaling.
Scaling law, galaxy mass versus rupture core size. Core radius RC increases with total galaxy mass MGAL. Predicted relation, RC proportional MGAL caret beta, where beta is theory dependent. Consistent with observed correlations. Matches empirical links between galaxy mass and central black hole mass. Role of coupling constants and ambient density. Scaling exponent beta, set by medium's coupling constants and background density S0. Allows for testable predictions across different galactic environments.
Comparison, strengths, and summary. Comparing to standard theories, gravity, curvature versus density gradients. General relativity, gravity from spacetime curvature, unified medium. Gravity from density field gradients, S. Particles, field excitations versus medium configurations. Quantum field theory. Particles as excitations of abstract fields, unified medium, matter as stable density, coherent structures. A single substrate for all phenomena, unified medium, S-Ugium, psi fields underpin gravity, electromagnetism, and quantum effects, eliminates need for separate geometric and quantum frameworks. Strengths and open questions. Unified explanation of physical phenomena. Gravity, electromagnetism, and quantum coherence emerge from a single medium. Matter and dark matter arise as stable or transient medium configurations. Resolution of singularities. Rupture zones replace black hole singularities with finite volume, high-density cores. Coherence collapses, but density remains finite, avoiding infinities. Open questions and future directions. Empirical determination of coupling constants. G1, G2, G3, needed. Behavior at extremely high energies and early universe rupture dynamics remain to be explored. Further modeling and observational tests required to distinguish predictions.
Key takeaways. Unified physical medium for all phenomena. Gravity, electromagnetism and quantum effects arise from three interacting fields: density S, directionality U micro, and coherence, perpetuity. Gravity from density gradients. Variations in the scalar density field S generate gravitational effects, with spacetime curvature emerging as an effective property. Matter and dark matter as medium configurations. Stable density coherent structures form matter. Transient density fluctuations act as dark matter analogues.
Rupture zones replace singularities. Critical density leads to finite volume collapse. Rupture zones, instead of singularities, preserving physical consistency. Conceptual clarity and unification provides a single physically intuitive framework for gravity, quantum phenomena, and matter formation.